All right, so you recently had this quiz. This quiz was actually a week ago today, looks like, on August 20th. And you have it back, but we haven't had a chance to go over it. So I thought I would let you go over it with me on your own time and make you a video. So here's the first page, key. And we're just going to go ahead and work through that. And remember, you can always go back and pause when I was showing you that if you want to see it a little more closely. So let's see. Number 1, 2 times square root of 18. Remember that I is the square root of -1. And what you have here is this. So basically, every time you have a negative under the radical, it's going to come out as an I, because square root of -1 is I. So here I have 2 times I times square root of 18. Now the square root of 18 can be simplified because it has a perfect square in it. This is 9 times 2. Another way of thinking of it is the prime factorization of 18 is 3 times 3 times 2. And since it's a square root, which means second root, 2 3's come out as a single 3 outside times the square root of 2. So here's 2 times I times 3 root 2. So the 2 times 3 we can multiply and get 6. The I stays I, square root of 2, and that's my answer. Next, -1/2 times I times the square root of 98. Remember, the negative under the radical comes out as an I. You only get an I when you have a negative under a square root. That's when you get an I. So square root of 98, let me think about how to simplify that. The biggest perfect square that goes into it is 49. So this is a 7 root 2. So I've got -1/2 times I times 7 square roots of 2. So 7 times -1/2 is -7/2 I square root of 2. That's my answer for number 2. Number 3, again, with the negative under the radical, it comes out as an I. And then I just have to simplify the square root of 12. 12 has 4 in it, so it's 4 times 3. That means the square root of 4 is 2. So we have 6 times I times 2 times the square root of 3. Anything that comes out is multiplied out front by everything else that's out there. This is all multiplication. Notice there's not a plus or a minus, so it's all multiplication. It's all one term, one monomial. So this is 12I root 3. And that's numbers 1, 2, and 3. Number 4. Here is where we are solving. And remember, this thing that was special about this is we are solving, and the only variables you see are variables that are squared. In other words, the x is squared here. I don't have any plain x that's not squared. If your only x is the one that's squared, then we can solve by taking the square root. But first, we have to get the squared part alone on one side. So everything else has to be moved away from whatever it is that's squared. And in this case, it's only the x that's squared. So this is when I can go ahead and take the square root of both sides. Take the square root of both sides. And remember, that's when you get a plus or a minus, when you take the square root of both sides. So I get x equals plus or minus square root of -27. So an I is going to come out of that. I have plus or minus I times square root of 27. Let's look at square root of 27. That's 9 times 3. So this is the square root of 9 is 3. So this is I times 3 root 3. Or plus or minus 3I times the square root of 3. Next one, same thing. My x is squared. I don't have any x's that are not squared. So I'm going to get everything that's not squared on the other side of the equation. Here I would multiply both sides by 4. It's multiplying by the reciprocal, 4 over 1 instead of 1 over 4. And these cancel, leaving me with x equals, x squared, I left off my squared, -48. So I take the square root of both sides. Plus or minus happens immediately. So what is the biggest perfect square that goes into 48? That is 16. So 16 times 3 is what I'm thinking of this as. So I have plus or minus The 16, remember like this, comes out as a 4. So I have 4, I have an I that has come out, and I have a 3 that's left over inside. So here's my answer for number 5. Next, number 6. This says find the values of x and y that make each equation true. Show your work. There were some of you who missed this. Some of you have struggled with this, and really, if you are struggling with it, I think it's because you don't understand how easy it is. It really is easy. All that you're doing here is you're saying this complex number equals this complex number. In other words, you have a number in the form a plus bi, and you have another number in the form a plus bi, and so you have to figure out what x and y would be to make these numbers equal. So the real parts, which are the parts that are just the number, have to equal each other, and the imaginary parts have to equal each other. And that's all you do on these. You look for the imaginary parts. That's the parts that have an I in them. So here's an imaginary part over here, and here's the imaginary part over here. This is all one term because there's not a plus or a minus separating these things. It's all one term because that's all multiplication. So I have my real parts, that's not the real parts. Let's do imaginary parts here. Imaginary parts, negative 20i equals negative 4 times y times I. I'm trying to solve for y. So the first thing I'm going to do is divide both sides by I. We really don't have to go through that step because look what's going to happen every time. So negative 20 equals negative 4y, divide both sides by negative 4, and y is 5, and that's all. Then I do the same thing with my real parts, 2x and 8. So 2x has to equal 8. So if 2x has to equal 8, then x is 4. And that's how you do it. Same thing down here. I find the real parts, that's the parts that don't have an I. This term does not have an I. This term does not have an I. Those are the real parts. So I say this real part equals this real part. Then I take the imaginary parts. This is the imaginary part over here. This is the imaginary part over here. And I say those things are equal also. Excuse me. So my real parts are 5 times the quantity x minus 1 equals negative 20. So I'm going to divide both sides by 5 and get x minus 1 equals negative 4. Add 1 to both sides, and x is negative 3. Then I'm going to say these two parts equal because they are both imaginary. The imaginary parts have to equal one another also. So I have 3 times y times I equals negative 15i. Remember what's going to happen from up here with those i's. As soon as I divide one side by I, the other side's divided by I as well. So really, those are just going to disappear. So I have 3y equals negative 15. So 3y equals negative 15. Divide both sides by 3, and y is negative 5. Remember, whenever you're watching a video I'm doing, I'm moving kind of fast to kind of save space, file space, but it's also because I can afford to move faster on a video because you can afford to listen to it 4 times if you need to, or stop me while I'm going, okay? So please make sure this is interactive for you. And I'm going to stop there. That's the end of the first page and resume on the second page.